Hey guys, so now we're going to look at our second similarity theorem, and that's the side angle side similarity theorem. So what this means is that if two pairs of sides are proportional, such as in this example over here, if we have like 6 and then 12, so we could do 12 divided by 6, and that's 2, so we know that's being increased by 2. Or if we have 10 divided by 5, so 10 divided by 5, that's also 2. So we know that those two sides are proportional there. So if we're on a good start for the side angle side similarity theorem. So if two pairs of sides are proportional and the angle between those sides are congruent, then the triangle is similar. So what that means is, so if we look at this side 6 and 5, we would need the angle in between those two. Blue's not a good color. So we would need this angle to be congruent if we have 10 and 12 to this angle in between those two. This angle right here, like angle M, that one wouldn't matter because it's not in between. This angle Q wouldn't matter because it's not in between, and the same with these ones over here. So we would need those two to be the same, and luckily, if we come back, we remember that these two are vertical angles. Because there are two intersecting lines, that means that these opposite angles are going to be congruent. So those two are congruent. So therefore, we could write that triangle, let's go M and Q is similar to triangle P and O. Okay, so let's go ahead and see if we can apply this. So on this first one with 2A, first let's check the sides because we need the sides to be proportional. So if we look at this side FE, that needs to be proportional if we just say to ML. So we'd have to do 36 over 9, and that would be equal to 4. And then we would look at GE, which is 37, and then NL, which is 9, and that's not equal to 4, because 36 divided by 9 is equal to 4, those 37 divided by 9 is not equal to 4. So these are not similar. Okay, now let's look at B. Let's go to green, why not? Okay, so if we look at B, we need our sides to be similar, so we need 27 and 9 to be similar. So we'd have to have 27 divided by 9, and that is 3. And then we would need to have 30 and 10 be similar, or proportional, sorry. And that would be 3 as well. So we know those two are proportional. Now we need to make sure that our angles are congruent. So we would need this angle to be congruent to this angle. But hey, what kind of angles are those? Vertical angles, because we have these two lines, they're coming in and intersecting. So that means opposite angles are congruent, so those two would be congruent. But we really don't care about those ones, we only care about those two there. So these two triangles are congruent, so triangle ABC would be congruent to triangle, let's see here, AVU. And then again, we have to complete it, so we'd have to put by, and we can shorten this side, angle side, similarity. Okay, so last application is C here. So we need these different sides to be similar. So we would have to look at 66, and this smaller one would have to be similar to what this bigger one is. And that 66 plus 11 is 77, so we'd have to have 77 over 66. So that gives us 7/6. I would simplify that down, or we can get a calculator to see specifically what it is. And then we would need this long side right here, which would be 8 plus 54, which would be 62. It needs to be similar to 54. We'd have to reduce that down. Let me actually figure out what these numbers are. So let me get a calculator. Hold on. Sorry, guys. Sorry. Thought I was ready. So 77 divided by 66. Let's erase that. So that would give us 1.16. And then 62 divided by 54. That would give us about 1.15. Yeah. It's not going to let me write there, is it? And so since these two numbers are not equal, that means these two are not similar. Alright guys, so that's the side angle side similarity. We'll move on to the side side similarity theorem in our next video.